Hello. Yes, we welcome you back again. The channel is PSSB, Physical Sciences Silver Bullet. This Richard. If you have not yet subscribed to the channel, we urge you to do that. It's to your advantage. Okay, we are still on this question. We are looking at this question number 2. The statement reads, the reaction between magnesium and hydrochloric acid is represented by the reaction below. So this is the equation. Okay. And the concentration of hydrochloric acid is given. The mass of magnesium chloride formed is given. The question says, define the term concentration. So what is concentration actually? There are several ways, several approaches to this one, but let us use the standard one, which we don't have to change till we leave secondary school. It is the number of moles in a given volume, number of moles of a substance in a given volume of a solvent, or number of moles per unit volume. That is concentration. Sometimes people use different units. Sometimes some people use mass per unit volume, but let us just use number of moles per unit volume. Thank you. Okay, then comes this question. The question says that calculate the volume of hydrochloric acid solution needed to react with magnesium to form 0.78 grams of magnesium chloride. So when you look at this scenario, you have to come to our equations. And first of all, we are given the mass of magnesium chloride which was formed. So you earmark it because you are going to need it. Then they say calculate the volume of hydrochloric acid. So we are going to also need that. So in other words, our tango is between hydrochloric acid and magnesium chloride. So what do? You have, you divide this section into two, like always. And what do we have this side? You have hydrochloric acid. And what do you have this side is magnesium chloride. The purpose of this is to give us the ratios. So the ratio is 2 to 1. And then you move. Which one is known? For hydrochloric acid, we know the concentration, but we don't know the volume. So we know our concentration is 0.15 moles per cubic decimeter. Okay, that's it. What we have so far. For magnesium, what do we know? We know the mass which was formed. The mass is 0.78 grams. Okay. And remember, like I told you, the moment you have 2 and 1, those are ratios. So whatever you do here, you must strive to get number of moles. So this is a dead end. We can't proceed. So this is going to be our unknown. Let us use the other side. If you know the mass and you need moles, it means that you are going to require this. the molar mass of magnesium chloride. Okay, let us get it. So we have our molar mass for magnesium. It is 24.3. Now having the mass and the molar mass gives you the number of moles. Through the equation, N is equal to mass over molar mass. So the mass is 0.78 and the molar mass is 95.3. This gives you the number of moles, which is, so we have our number of moles. These are the number of moles of magnesium chloride which were formed. It's 0.0082 moles. Okay. Now, remember, you have this. You have the ratios. These two. You have that one. You have the number of moles here. So, if you want to find the number of moles this side, it's going to be number of moles of each cell which reacted. Let's call it X. Like I always tell you, these are directly proportional ratios. So you cross multiply, you're going to get X equals to 2 times 0.0082. And what do we get out of this one? Okay, so now we know the number of moles. We know the number of moles of hydrochloric acid which reacted. Now you have to remember that if you know the concentration and you know number of moles, then you know the volume through which equation, through the equation which says C is equal to N over V, where C is the concentration, N is the number of moles, and the V is the volume. So what do we do here? Our C is known is 0.15 and our number of moles is 0.0164. This one over V. So you get this volume by cross multiplying. And what do you get here? You're going to get V is equal to 0.0164 over 0.15. What you get there will be the volume in cubic decimeter. That's the volume of hydrochloric acid which reacted. Okay. So this is the volume which is volume of hydrochloric acid which reacted. It is 0.19 cubic decimeter or 109 cubic decimeter. Okay, let's go to the next question. Yes, then comes this question. The question says that if the reaction takes place at STP, standard temperature and pressure, calculate the volume of hydrogen gas formed during the reaction. So how do you go about this? Still, I would advise you to use the same method. It's universal. You divide this one into two sides. You have to take note that this time around we are looking for hydrogen. So hydrogen is part of the deal. Okay. Then you are given this. We can't start from hydrochloric acid because unless you use the previous calculation. So for magnesium chloride, we know the mass which was given, and it is 0.78. So what do? You put this side, it's magnesium chloride, and this side you put what? Hydrogen. The ratios are 1 to 1. The known is magnesium. We know the mass. The mass is 0.78 grams. The molar mass of magnesium, we found it already in the previous question. It's going to be, it's magnesium chloride, sorry. It's going to be 24.3 plus 35.5 times 2. Okay, we got 95.3. Yeah, that's what we have, grams per mole. From there, you have to remember that when you have the mass and you have the molar mass, then you can easily get the number of moles through which formula? Through the formula which says the N is equal to mass over molar mass. So in this case, what is our M? 0.78. And what is our molar mass? 95.3. And we get our number of moles as. So those are the number of moles. So after getting number of moles, this is what you have to know, that the mole ratio is 1 to 1. And this time around, this side, what are we finding? We are looking for number of moles of hydrogen, which can call X. And you need to remember that if you have this, and you have this, and you have number of moles, therefore we can easily find X. These are directly proportional ratios. So when you cross multiply, what do we get? It's 1 to 1, so you don't even have to do. X is going to be the same as what? As this one, which is 0,0082 moles. Okay, those are the number of moles of hydrogen which is formed. But the question is looking for the what? For the volume. So the question which comes now is, how do we convert number of moles to volume? The question is there. It is number of moles equaling to volume over molar volume. So in this case, what do we have? Number of moles are known. They are 0.0082. And the volume is needed. But remember, we said that the reaction took place at STP. The standard temperature and pressure, at standard temperature and pressure, the molar volume is 22.4. So you get what you have here through cross multiplication. And what's going to be your answer? Your answer is going to be 0.0082 times 22.4, giving you the answer which you are going to get after computation. So there comes the answer. The volume is 0.184 cubic decimeter. Okay, so that marks the end of this question. If you have not yet subscribed to our channel, we would urge you to do so. Yeah, see you. in the next video. Bye bye.